I'm going to look at 2019 question 3. It says, a mirror A, B, C, D, E is designed in the form of the sector of a circle. Well, first of all, I like to draw out myself to see what's going on. So you've got down here one triangle, an identical triangle here, and you've got your sector of a circle. A to C, so this whole line is 80. So we're 40 from here to here, from here to here. And we're told that AE equals CD, which is 60. So that's 60. So first of all now, I'm very conscious that we have a sector of a circle in there. For a sector of a circle, you need to know the angle in there. The question is starting by wanting you to find angle EBD. EBD is looking for this angle. First of all, I'm going to find this angle here. Now, if you can see, you have got a right angle triangle. So we're back to GCSE and back to trig. 40, 60, and this is your angle. Label it just your normal way, hypotenuse, opposite, adjacent. You have the opposite and the adjacent. So using your SOHCAHTOA, it's going to be A and O. So tan the angle is opposite, which is 60, over adjacent, which is 40. The only thing now, when you're putting this into your calculator, make sure your calculator is in radian mode, because you can only use the formula for sector if it's in radian mode. So just your normal shift tan 40 divided by 60 gives you an angle of 0.98279. Now do keep a few decimal places going there. To find the required angle that they are looking for, I'm going to call it theta. What I'm going to do is a straight line. And remember, a straight line is pi radians. So it's pi, take away 2 of the a's. So 0.98279. Keep your calculator accurate and just go times 2 and then pi, take away the answer, giving you an answer of 1.176. Now, you tend to in A level give your answer to 3 significant figures, so I would just write 1.18 as my final answer. Now, that was part A, part 1. If you look at part 2, it wants you to find the area of the mirror. So that was part 1. Part 2. So the mirror, as you can see, is made up of 2 triangles and 1 sector. So the area of one triangle is just going to be base times height. So area of one triangle, base times height divided by 2. 60 times 40 divided by 2, which gives you 1200. So area of 2 triangles is going to be 2400. Now, we want the sector. Sector area is a half r squared. It's a half r squared theta. So it's a half r squared theta, which means I need to know the radius. If I go back to my triangle, I need to know r. I can do that quite easily as over the side using Pythagoras theorem. So r squared equals the 2 at the right angles squared and add it up. To find r, you'll just square root that. So 60 squared add 40 squared equals 5200. Just square root your answer in your calculator and you will get r to be 20 root 13. So my sector area is a half times 20 root 13 squared times your theta. Now use a more accurate answer if you can. So I have this my calculator, just square it, divide it by 2, times it by 1.176, gives me an answer of 3057.6. So the total area of the mirror is the 2 triangles plus the sector. Adding these up gives me an answer of 5457.6. Try to give it to 3 significant figures. 5460 centimeters squared.